Okay, so our last shape that we need to talk about is squares. So squares are like a super shape because they have all the properties of parallelograms, rectangles, and rhombus, all of those together at once. So we're going to write what all of those properties were. We're writing down in these notes, and you should probably write them on your paper at home. But first of all, we know that the diagonals bisect each other. So that means, first of all, we got to draw in the diagonals. Those are the diagonals. And they bisect each other. That means they cut in half. Cut in half. So that means that the parts are equal. That's like the sort of equation we should be doing is if they give you parts of the diagonal, we know all of the parts are equal to each other. So if they give you the parts, set them equal. We also know, what else do we know? That the diagonals themselves are equal. So the whole line and this whole line are equal. So if you can't see, the letters are A, B, C, and D. That's from a rectangle. That was the same one in rectangle. So we know that BD is equal to AC. So if they give you the two diagonals, you set them equal, you solve for X. What else do we know? We know that diagonals are perpendicular. Diagonals are perpendicular. So we're going to draw them in, draw them in. So what does that tell me? Perpendicular means they make 90-degree angles in the middle. Angles in the middle. Okay, so I would put 90 in all the angles in the middle. Okay, we also know that all the sides are equal to each other. Because, like, hello, that's like the main thing we know about the squares. So the sides are equal. So if they give you two of the sides, set them equal. So I'm going to put tick marks on all the sides because they should all be the same thing. All right. And the last one, we got to talk about the angles in the corners. Okay, so first of all, we know that there's 4 right angles. That means in the corner of the shape itself, all of those are 90-degree angles in the corners. We know that. Duh. But we also know that if there's diagonals, we know that the corners also get cut in half. So since the corners are always the same thing, we know each side is always a 45-degree angle. Both sides, 45, 45. And all the corners are 45, 45s. So if they ever tell you like what the little angle is and they ask you, well, what is the little angle in the corner? You know it's 45 because it's a square. 90 gets cut in half. So all the little corners are 45. If they give you the whole corner, we know that's 90. So with all of this information in mind, let's do some questions. So number 1, I'm looking at the shape. What information did they tell me? Did they tell me about sides or angles or diagonals? Now they have the diagonals drawn in, but the information they gave me, the 4x minus 1 and the 5x minus 6, those are sides. And what did we just talk about? About the sides of a square, we know they're equal. So we're going to set these two things equal to each other. So 4x minus 1 equals 5x minus 6, and we're going to solve for x. So I move x's to the same side. That leaves me with negative 6 and negative 1, and 4x minus 5x is negative 1x. And then I'm moving the negative 1 to the other side by adding 1. Cross this out. Negative 1x equals negative 6 plus 1 is negative 5. And then divide by negative 1. And I get x equals positive 5. If you don't know, you would type that in. And the question just said solve for x. I do not need to plug it back in. So this is my answer. They give me any of the sides, we set them equal because all the sides should be the same. Okay, the next one. It says solve for y again. I'm looking at what they gave me. Did they give me sides, angles, or diagonals? Well, the thing we're talking about, the 4y plus 26, that's the angle in the middle. What do we know about the angles in the middle is that they're 90 degrees. Oh, okay. So we'll write that down. Angles in the middle are supposed to equal 90. So that's the equation we're going to write, is that this equals to 90. So what am I writing? 4y plus 26 equals 90. And that's the equation we're going to solve. So I got to move the 26 to the other side. So minus 26. 26 goes away. 4y is still here. 90 minus 26 is 64. And then divide by 4. Divide by 4. 64. You would type this in your calculator. 64 divided by 4 is 16. And it just said solve for y. I do not need to plug it back in. So that's it. So angles in the middle equal 90. So I set it equal to 90. Number 3, solving for x. Now, in this one, they gave me parts of the diagonal right there. But we know this triangle in the middle, that's a right triangle because the angles in the middle equal 90. And if I'm trying to solve for x, I'm going to use a squared plus b squared equals c squared to figure that out. Now the problem is, like, I know across from my 90, this is c, and this is a and b. But I don't know what b is right now. Or do I? They tell me that this part over here is 8. And according to our notes, all diagonal parts are equal. So that means over here, this is also an 8. And now I have 8 for A and 8 for B, and I'm solving for x. So we're going to write that down. 8 squared plus 8 squared equals x squared. I know I could put 8 on all parts of the diagonals. This is 8. This is 8. Over here is 8. 8, 8. All over. All the diagonals. So we're typing this in the calculator. 8 squared plus 8 squared. You're typing in the calculator. You get 128 equals x squared. And then we're square rooting. Square rooting. So the square root of 128 is 11.31. 0.31. Round to the nearest tenth. Does the 1 make the 3 bigger or keep it the same? It's going to be the same. 11.3. Final answer. We should add this to our notes. Where should we add it? The diagonals are perpendicular. We should add that. It means the 90 in the middle, and I can use a squared plus b squared. Okay. That's possible. All right, last example. They said Jn equals 4x plus 13. So we are going to label this in our picture. So on Jn, I'm going to put 4x plus 13. Great. And nk right here is 6x minus 11. What is Jn? So what did they give me? Well, they gave me parts of diagonals. I know it's not the whole, that's G, diagonal. I know it's not the whole diagonal because the whole way across would be J to L, and they only gave me J to N. So what do I know about the parts of a diagonal? Parts are equal. Oh, that's handy dandy. Here we go. Parts of a diagonal are equal. So I'm going to write that these two things are equal. So 4x plus 13 equals 6x minus 11. We're solving for x. So subtract. I need x's on the same side. Negative 11 is here. Positive 13 is here. 4 minus 6 is negative 2. Now we're moving 13 to the other side. This goes away. Negative 2x. Negative 11 minus 13 is negative 24. Divided by negative 2. I get x equals positive 12. Final step. Did it ask me to solve for x, or did it ask me to plug it back in? It said, what is Jn? That means I got to plug it in. So where is Jn? Here's Jn. So I got to plug what I got. So what did I get again? I got 12. So I'm plugging it in for x. So I have 4 parentheses 12 plus 13. I'm typing all of that in Desmos all at the same time. This is me typing it in Desmos, and I get 61. So I know that JN should equal 61. So with all of this is just combining all of the rules that we have practiced you're using on squares. So you're going to go ahead and start the formative.